All right. I want you to take a few moments now to fill in this formula. You can see what I'm writing the formula for. I'm writing it for the product of f and g. So if we have two functions being multiplied, and we want to do the derivative of f times g. So it will be the derivative of the first function multiplied by the second function as it stands. So the derivative of the first one, your f of x, done as usual, but then multiplied by the second function as it stands. Don't do the derivative of that one yet. Then put a big plus sign. And now the other way around. Just leave the first function as it is, f of x, and multiply that. My box isn't big enough here. By the derivative of g of x. So each one gets a term for the derivative. Each one gets a term. In words, you could do it like this. Derivative of the first, leave the second one as it stands, then leave the first one as it stands, and the derivative of the second times the derivative of the second. So the product rule is a little unusual because in the answer of it, only part of it is made up by a derivative. The other two parts are made up by the original functions themselves. So derivative of the first function times the second function as it stands, and then the other way around. They each take a turn. So then the first function as it stands times the derivative of the second function. Or if you like it in words, it's stated for you right here. Another way to write it would be like this. If you have the product of f times g, and you want to take that derivative, it would be quite simply f prime g plus f g prime. So that's without all the brackets and the d's being written. That's about as simply as we can state it with variables. So f times g prime, f prime g, f g prime, f prime g, and f g prime. Okay. Let's take a look at a very quick proof of the product rule. Okay. Suppose we define capital F to be the product of little f and little g. So we're defining capital F to be f times g. If we take its derivative with first principles, we could write it like this. Okay, now, this is a really good exercise for all of us here. In first year university calculus, they will be doing a few more proofs with you. And so it's very, very important that you understand this proof. Okay, so this is the definition of the derivative for capital F, right? Capital F is defined as little f times little g. So when we do this derivative formula, we start by substituting x plus h, which I've done here. And then we just substitute x, which I did there. So remember what capital F was. It's the product of the two. So that's why both of them are there. Okay, so we're going to work with this one a little bit. This gets a little bit complicated, so I hope you can follow me here. I'm just going to write down the first term again. So there's my first term written down exactly as I had it over there. And I'm going to leave a big space and write down my last term over here. And I still have my h down here, waiting patiently. But in between, using the purple pen, which looks green, I am going to add two terms that exactly cancel each other out. What are they? F of x plus h times g of x, and then the exact opposite, the positive version. Look at these two purple terms. They're exactly equal to each other, except one's negative and one's positive. By introducing these two terms, did I change the expression? No. You may not know why I added those two terms yet, but I do, and you're going to see why. You're going to see why in a few moments, okay? You'll see why. But I want you to agree, first of all, that what I did is mathematically legal. This is legal. I subtracted something, but then I added the very same thing. Okay, so nothing has changed there. I am now going to break it in to two limits. All right? Do you notice something in common here? Look at this. Do you see that there's an fx plus h in common? Okay. We're going to factor that out. All right, so I'm going to factor out the fx plus h. What would be left in the bracket from the first two terms if I factored out the f of x plus h? Yes, g of x plus h minus g of x. And then in the last two terms, what's in common? What's in common in the last two terms? G of x. So take it out. And then what do I have? F of x plus h minus f of x. No, you don't have to memorize all this. You just have to understand it. Okay. Now, what I hope you now recognize is this and this. Those two brackets should be recognizable as part of their derivative formula. That's what the derivative formula numerator looks like for G, and that's what the derivative formula looks like for F. So guess what we have going on here? We have a regular F. See, once h goes to 0, right? Once h goes to 0, this will be f of x. So once that happens, that'll be f of x. So let's write this down. So there's our first two terms written again. And there we go. I have just, believe it or not, I have just proven my case. Because this one right here, as h goes to 0, this one will be f of x. This one is the derivative of g. This one right here is g of x. And this is the derivative of f, which is the product rule. Whoa, that was quite an experience. Okay. Okay, I want to just give a brief disclaimer about this. There are some things that Math 31 teachers do for the information of the students. We will not test this on a test. Okay? This is for your viewing pleasure and to make sure that you understand that we just didn't pull this formula out of thin air. There is a mathematical reason for it, and this is the reason. This is a pretty advanced proof because it involved introducing these two terms without knowing why. This was proven a couple of hundred years ago by a fairly brilliant professor, and someone who knew how the end had to end up and then adjusted these terms accordingly. So sometimes if you know how the end of the story is supposed to end up, you can write the middle. Okay, so g prime x is this part right here. Now remember the formula. Okay, where did we get it? From the step before? The step before, it's right here over h. Remember, these are all over h, right? So is this one over h. So gx plus h minus gx over h is the derivative of g, right? The limit as h goes to 0 of these two minus each other over h is part of our derivative definition. And this one over h is the derivative of f of x, right? Okay. So that was, I hope you got it down. And don't panic too much if you didn't get every step. I guess what I want you to take from it is this. The product rule is verifiable and provable. Okay? Let's take a look at now this question right here. We're going to start with an easy one. Now, I think I'm losing a few of you. Okay? Okay. Yes? Yes, and that's what I was going to point out, is that this one can be multiplied out, and then you can do it with sum and difference, right? But there are some coming up where you won't be able to multiply them out, okay? Not on this lesson, but in future lessons. And so we are going to use the product rule on this one, okay? I'm still losing some of you. Okay. So what we will define, our f will be 2x cubed plus 5, and our g will be 3x squared minus x. Okay. So now we've defined our f, we've defined our g. What does the product rule look like again? What's the derivative of f times g again? Well, we just learned the formula. It's f prime g, f g prime, right? So it's a very easy formula to memorize. So on this one, if we want y prime, we take the derivative of the first one, 6x squared, plus the derivative of 5 is 0. Then we write down the other function as it stands. Then we always put addition, never subtraction. Right? Always addition. It's part of the then we just write down f 2x cubed plus 5. And then we take the derivative of g. The derivative of g is simply 6x. Underneath, I'm going to put what each one is. Okay? There are 4 parts here. So first of all was f prime. Then was g. And then we had f. Oh, sorry, minus 1. Thank you. Minus 1. Don't forget the minus 1. Okay, then we have g prime. So there's 4 parts to every product rule. Your f prime, your g, your f, your g prime. Okay, so could you simplify that for me? Go ahead and simplify it. What do you get? Our class, do you like my answer? How many would vote it in? You'd say that's what I got too. Okay. Now, what you could do is you could FOIL out the question first, right? And then take the derivative with last class's method. You wouldn't have a product anymore, so it's just sums and differences. You should get exactly the same answer. Yes. This one? Oh. No, I think this one's, they're both negative. Yeah, they're both negative. So here, negative 1 times negative 2x cubed when you're FOILing. And here, 6x squared by negative x, so negative 6x cubed. That's okay. That's good. All right. Yeah, that's the final answer. Now, I am going to make an executive decision here. For letter B, letter C, and number 2, we will not be simplifying our answers. We'll just be stating the answer, but not simplifying. That's pretty standard across the city in the Math 31 course. We don't necessarily want you to spend a lot of time simplifying complicated expressions. We're more interested in the calculus than in simplifying things. So when it's easy to simplify like we did in A, then yes, it is expected. But for a question like B, I'll be happy if you get the right product rule answer. Okay? So how about I'll do B, and then I'll assign C in class, and I'll walk around and see how you're doing with it. All right, so let's try this one. The first thing I'm going to do is rewrite. So I'm going to rewrite as 1 minus t to the negative 1 plus 2 times t to the negative 3 t plus 1/2 t to the negative 4 minus 4 t to the negative 5. Now, why did I do that? So I can take advantage of the power rule. Oh, getting too excited. The power rule, right? So the power rule is friendly with negative exponents, right? So the power rule is usable here. Now, while you're starting with this, it might be helpful to label some things like f and g. So this is our first function. It might be helpful to always start with the derivative of the first function. So we're going to start with f prime, then we'll write down g. So what will f prime be? So we want f prime of t, right? What will f prime of t be? It'll be the first function, our f, so it'll be 0, which we don't have to write, and then negative t to the negative 2, and then plus 2 times the derivative of t to the negative 3, which is negative 3 t to the negative 5. Oops, where am I? Negative 4, sorry. I was looking at the wrong one. And this, my friends, is the derivative of our first term, f. This will be multiplied by g as it stands. It won't change. Okay, we need a lot of room to write the answer to this question, don't we? So now, so what I did was I did the derivative of f. Remember, the derivative of 1 is 0. Then we have negative times negative t to the negative 2 plus 2 negative 3t to the negative 4 for that one right there. Now the other way around, I need to write down f as it stands. So 1 minus t, negative 1, plus 2t to the negative 3, and then multiply that by the derivative of g. Need more room. The derivative of g would be 1 plus half, brackets, negative 4t to the negative 5, and then negative 4 times the derivative of t to the negative 5, negative 5t negative 6. The only simplification that you might do is just a term-by-term simplification. The other thing to keep in mind is that even though we won't be multiplying out our brackets here, we should give the answer in the same form that we started with. So if we started with terms that are in the denominator, positive exponents, we should try to end with positive exponents. All right, so f prime of t then will be, the negatives will cancel here. So you'll have 1 over t squared. And then this will multiply through, so that'll give you negative 6 over t to the 4th. And then this bracket right here, t plus 1 over 2t to the 4th minus 4 over t to the 5th. We're halfway there. And then plus, next bracket would be 1 minus 1 over t plus 2 over t cubed. And then this bracket right here, 1 minus 2 over t to the 5th plus 20 over t to the 6th power. Once again, either I'm writing too big or whatever, but I'm running out of space on all of these questions. So that is an appropriate amount of simplification for this question. So whenever we had a couple of negatives, we wrote the positive, and we ended up with positive exponents throughout the whole expression. All right, class. I'll get you started with the next question, g of x. Yes, yes, you can. You don't have to show all those steps. All right, so here I would rewrite this as 4x to the half minus 6x to the 3 halves. Here this one, x to the 5 halves, and then plus 2x to the negative half. If you rewrite your original function like that, it might be a little easier to take your derivatives. So I promised that I'd let you guys do this one, so go ahead. You can do it. The quizzes took a little longer today, so we're not going to have a lot of in-class work time today. So for this one, I will write the final answer. Some of my x cubes are hard to read, but that's an x cubed, 1 over x cubed. So we have f prime, we have g, we have f, we have g prime. All right. If you couldn't get that one down, just copy the answer in red there, and maybe for homework, go through that one. Make sure you get it. If they ever do give you a polynomial function like in number 2, it becomes really easy to do, especially if they don't require to simplify. So for number 2, this question can be done in less than a minute. Yeah, less than a minute for this one. What's that? Oh, that's a printing mistake. That should not be there. Yeah, it should be just y. So that should, because obviously you found it then. Find y prime. There it is. Okay. All right, so this is supposed to be a y. It's a printing error. Sorry about that. Okay. Look at this. Y prime. In just a few heartbeats. Take the derivative of the first bracket. 1 minus 8x cubed. Done. Write down the second bracket. 3x 8 plus 5x squared minus 6. Put a plus sign. Write down the first bracket. And the derivative of x8 is 8x7, right? So 8 times 3, 24. And here we got 10x. And done. So if no simplification is required, you're already done. Derivative of the first bracket, write down the second bracket. Write down the first bracket, derivative of the second bracket. Done. Yes. Yes, you may. Okay, let's try a tangent question here. We want the slope of the tangent at the coordinate given. Can I give you some advice here? If your derivative is going to be pretty complicated, do not simplify the derivative. Leave it unsimplified and substitute in the x equals -1. It'll be easier that way. I promise you. Right? So much easier to work with the numbers than the variables. So let's do our y prime. Remember our y prime, quite simple. It's all polynomials here. So the derivative of the first one, 6x squared minus 4. Write down the second one, 8 minus 3x minus 7x squared. Put a plus sign. Write down the first one. And quickly do the derivative of the last one, -3 minus 14x. So there it is, sitting pretty, waiting for your substitution. Just like always, we take the derivative, and if we want the slope of the tangent, we substitute in x equals -1. So if we write f prime of x here, we're going to put -1 in here. So 6, -1 squared minus 4. 8 minus 3 times -1 minus 7 times -1 squared. And then plus 2 times -1 cubed. I didn't mean plus. Minus 4 times -1 plus 1. Last bracket, -3 minus 14 times -1. So at all points wherever I've seen an x, I've now substituted in -1. So yes, the derivative was more complicated, but the procedure is exactly what you did before. Substitute in the value, the x coordinate. So what is this going to give you? This is a positive one, so 6 minus 4 is 2. Over here, working backwards, -1 is squared, so we have a -7 there. So we have 8 plus 3, 11, minus 7 is 4. And then over here, -1 cubed is actually -1. So this is -2 plus 4, -2 plus 1, -1. And then over here, -3 plus 14, 11. Did I make a mistake here somewhere? 2. This should be 6 minus 4. That's 2. This is -1 squared is -7. 8 plus 3 is 11. 8 plus 3 is 11 minus 7 is 4. Is this the one that's wrong? Okay, so -2 plus 4. So -2 plus 4 is +2. That should be a 3. That's it. I knew there was a mistake here somewhere. All right, so I think the 11 is right, though. So we have 8 plus 33. We have 41. Okay. All right, so we just have one more to do. No, 2 more, sorry, but they're very short. Okay, assuming f is a differentiable function, find an expression for the derivative. Well, Here's your two expressions. Your two expressions are x cubed and f of x. So when you do the derivative, it's the same thing. Take the derivative of the first one, 3x squared. Write down the other one as it stands, f of x. Put a plus sign. Write down the first one as it stands, and then do the derivative. There's no simplification possible, so we leave it like it is. That's all we can do with that one. Okay. On this one, there's a printing error again in your book. This should be a 4. F of x, f times g of x substituted by 4 would be this. It would be the derivative of the first one with 4 substituted, multiplied by g with 4 substituted, then added f with 4 substituted, multiplied by g derivative with 4 substituted. So it's the same pattern, f prime g, f g prime, but now there's 4's in there instead. Did they give you all 4 of those in the information? Yes. So just sub them in, and you're done. Try it. It'll be fun. Okay. 3 times negative 2 plus 2 times 6. Negative 6 plus 12 is 6. Yay, that's right. Okay, is there an assignment? What's that then? That's a big typo. Should be. That should be okay. Yeah.